The binomial distribution as a model. Shahir catches a train from his local station. He claims that the probability that the train arrives on time is 0.4 and that the train's arrival time is independent from day to day. Assuming Shahir's claim to be valid, determine the mean and standard deviation for the number of times during a week, that's a week of 5 days, that the train arrives on time. Okay, this can be modeled with a binomial distribution with 5 trials, and the probability of success in one of those trials is 0.4. So this is n, the number of trials, and p, the probability of success. Going to the formula book, the binomial distribution, the mean has this formula, n times p, and the variance has this formula. And we can use these two to work out the mean and standard deviation. Okay, let's do the mean first. Okay, so the mean is equal to n times p, which is equal to 5 times 0.4. which is 2. Okay, so the mean is 2. The variance is equal to n times p times 1 minus p. So that's 5 times p, which is 0.4, times 1 minus p. That gives a variance of 1.2. So the standard deviation, which is the square root of the variance, square root of 1.2 gives you 1.1. So the standard deviation is equal to 1.1. For a period of 13 weeks, Shahir records the number of times that the train arrives on time. His results are as follows. So now we need to see that does this data fit the binomial model. Back to the calculator. Let's reset the calculator first. Shift 9 3 equals, that's all reset. Mode, statistics, one variable, put the data into the calculator. Okay, so there's 13 data values in there. So shift 1 for statistics, option 5 here for variables. The mean of this data is 2. So the sample mean here is 2, and the sample standard deviation, shift 1 5, that's option 4 for the sample standard deviation, is 1.15. Let's compare these values to the ones that we have already worked out. The mean here is 2, and that was exactly 2. The mean here is also exactly 2. So the means are identical. Means are identical. They don't have to be identical for the claim to be valid. We're looking for means which are similar. So if there is a less than 10% difference between the means. Okay, the standard deviation here is 1.1. The standard deviation here is 1.15. So the standard deviations, they're not identical, but they are similar. So the means are identical, the standard deviations are similar. That means the claim is valid.